Welcome to Structural Engineering Lectures by Cell Thinking. We will be covering the following topics in this class. First is what are equilibrium equations? Second is why do we use equilibrium equations? And we are going to see an example on how to find support reaction in beams using the equilibrium equations. Okay, now before I move on, I want to say that I'm really happy about you are watching my video lectures. This is the only reason I am making video lectures on strength of materials. I will be happy to know about you. Please, if it's possible, please comment in my video about you. Tell me about you. What do you do? And it will be nice to know each other. So please comment. All right. So let's begin. So let's begin first about what are equilibrium equations. Okay, I will give you the real life examples of why we use the equilibrium equations. Okay, and why do we use them to find the support reactions. Okay, now what are equilibrium equations? Now maybe you might have seen some things like summation of fx equal to 0, summation of fy equal to 0, and summation of moment equal to 0, right? If you don't know about these, I will not be talking much about them right now, because first I will tell you some real life example. Okay, then you will understand what are these equations. Okay, now first let me ask you a question. Okay, let me ask you a question. So the question is, have you seen a building moving? Have you seen a building moving or rotating? Okay, when you see around, what do you see? The buildings are moving like cars? Are they like rotating? No, of course not. What do you see? You see them at rest, right? When you look around the buildings or anything, the civil structures, you see them at rest, right? Unless, of course, there is not an earthquake, right? Because when there is an earthquake, everything moves. Anyways, the construction projects, the buildings, they are at relative rest with respect to the earth, right? Now what does it mean? In physics or in engineering, we call this rest, like, there's a fancy word for rest. It is static equilibrium. Okay, this is just a fancy word, don't worry. What it means, it means the buildings or whatever the body you're talking about, if it is in static equilibrium, it means that body is in rest. Okay, now what does it rest mean? Now rest, okay, it means two things, right? It means not moving, right? Like it is not moving, the building is not moving in horizontal direction, the building is not moving in upward direction, right? It's not moving upwards, it's not moving sideways. And rest also means not rotating, right? Not rotating. You don't see a building, okay, which is rotating, right? Now this is the reason when you talk about a beam. Okay, a beam is what? A beam is simply an element in the building or a construction, okay, which is normally horizontal, okay, and it is supported on the columns, right? Let us suppose this is a column and here is another column too. You might have seen the buildings like this. This is the column and this is our beam, right? Now when you see the beams in a construction building, at a construction site, you don't see this beam moving. Do you see this beam moving? Okay, if you see this beam moving, you will be scared to see the beam moving. You will think that this is an earthquake. Okay, so the static equilibrium is important. Okay, the resting of this beam, or the static equilibrium is important, right? It is important. And when we, as civil engineers or structural engineers, we don't want things moving. We want them in an equilibrium. We want them stable, right? Now, it means the net force on it is zero, right? Because you know, in physics, when you say like this is a body, okay, a force is acting on it from this direction. Let the force is 10 kilonewton, and a force is acting here of 10 kilonewton, right? Now, because of 10 kilonewton and 10 kilonewton, and they are towards each other, tell me, will this thing move in this direction? No. Why? Because when you see, let me assume axis like this is x-axis and this is y-axis. Okay, they are positive. Now this 10 kilonewton is in x direction, means it's positive, so 10. When I add up all the forces, now this 10, okay, it is opposite to this arrow, so it is negative 10 is equal to 0. What does that mean? It means summation of forces in x direction is 0, right? When the summation of forces in any direction is 0, the body will not move in that direction. Okay, uh, that is, we might have seen this rule in the physics, right? Now if here instead of 10 kilonewton it is 9 kilonewton, okay, now here would be 9 minus 10 is equal to what? It is minus 1, right? Now this 10 is more than 9, the net force will be what? In what direction? In this direction, and the magnitude will be 1 kilonewton, right? 1 kilo. Negative means what? Negative means it is opposite to this arrow. Okay, that's why we get this negative. When I get negative 1, I for sure I know the direction is like this, because our positive direction is like this, right? Anyways, because of this net force, the body will move in left direction, right? It means when the summation of forces in x direction is not 0, okay, the body will move. Okay, the body will move means there will be no resting, means no static equilibrium. Okay, means we don't want that building, right? Of course we don't want that building. Now if I consider the forces in the y direction, I think you get the idea. Now if I consider this as 10 kilonewton and this as 10 kilonewton, okay, now this is positive direction, okay, upward vector. Let us say this, I write 10 here, then this is plus, now this is opposite to this vector, right? It is going to be minus 10, right? So 10 minus 10 is 0. Okay, it means there will be no motion in the y direction. Okay, there will be no motion. That means there is rest, there is static equilibrium, right? Now the summation of forces in x direction, how do we write that in mathematical? You know, the word for summation is like this, right? In mathematics we write, if we want to write summation of something, we write summation forces. Let us denote the forces with f. Okay, in x direction let us denote it with a subscript x equal 0. Okay, that's what I write here. Similarly, the summation of forces in the y direction is 0, so here we will write y, right? That's why I write this. Okay, it means when summation of fx is 0 and summation of fy is 0, there will be no translational motion. Okay, there will be no motion like this. Okay, like this left right, or summation fy means there will be no motion in up down, right? That means this is the reason when we talk about static equilibrium, we say summation fx equal to 0, summation fy equal to 0. Okay, when there is static equilibrium, when the body is resting, it means summation fx equal to 0, summation fy equal to 0, but also summation of movement is 0. Now what is this? Now I have asked you the problem in the beginning of this funny class. Okay, that have you seen a building rotating? No, right? You have not seen the building rotating. Have you seen a building like this? Suppose this is a building, okay? Have you seen it rotating like this? Or have you seen it rotating like this? I mean like this and then this, okay? You have not seen this building rotating about any point, right? Because if that is the case, means there is something wrong in the engineering. Now, when we say the summation of movement is 0, what does that mean? That means there is no rotation. Now you'll ask how? Now let me show you here. Let us consider this beam, okay? Now let us consider a force acting on it like here, okay? Let me assume there is a hinge. You know the hinge in the doors which lets them rotate, okay? Now tell me, when you apply this force, or let me apply this force here, doesn't matter. For simplicity, I will apply the force here. Now tell me, when you apply the force on this, will this rotate? Now there is only hinge, right? Hinge means pin, the thing in your door. Consider this like your door, okay? For example, it is the top view, okay? The top view of your door. When you put your hand here and you push it, of course the door will open like this, right? It will rotate. It means it will rotate about this point, right? Now, if I ask you what is the moment of this force F at this point, let the length be L, okay? Now, what is the moment at this point? The moment at this point, let it be denoted with M. The moment is force multiplied by length, right? Now, force is not 0 because you are pushing the door. There is some force. Now, there is some width of the door, of course, as always. L is not 0 means this moment is not equal to 0, right? When the moment is not 0, it is rotating, right? Now, when I say the moment is 0, what does that mean? It means either when I say the moment is 0, okay, how it is possible? Either I am applying a moment here, okay, against this moment, it means here is no hinge, okay, this is a fixed beam, okay. For example, when you have a beam like this, okay, and it's fixed, right? Now you apply the force here, this force will exert a moment here, and this, because it's fixed, there is no pin, okay, or hinge, it will exert a force like this. It means the net moment is 0, right? Then it will not rotate. So yeah, this summation of moment equal to 0 is something that is related to the rotation, right? It means when the summation of moment is 0, it means no rotation, okay? Now tell me, when I say the body, a building is at rest, what do you say? It means it's not moving in the x direction, it's not moving in the y direction. and of course it is not also rotating, right? There is no rotation. Okay, that means when you talk about static equilibrium, therefore two things are important: no motion, right? Or rather, I would say no translational motion and no rotational motion. Okay, I will just write the simple layman words for understanding. It means no motion. Now no motion means no motion in x and no motion in y. Now what does that mean? When this is possible, there will be no motion in x when summation of force in the x direction is 0. There will be no motion in y when the summation of forces in the y direction is 0. And there will be no rotation when the moment is 0. Moment at any point, okay? That is the meaning of static equilibrium, okay? And I hope now these things make sense. Summation fx equal to 0, summation fy equal to 0, and summation moment equal to 0. I hope you understand the problem 1. What are equilibrium equations? Okay, I think you get the answer, and I hope you will never forget this. Now the question is, why do we use equilibrium equations? Now we use equilibrium equations for different applications, and one of the applications is to find the support reactions. Okay, to find the support reactions. Now again the question is, what are support reactions? Maybe you know what are support reactions, okay, or maybe you don't know. So let us try to understand the another problem. Why do we use equilibrium equations? So let me erase all of this first. Okay, now why do we use equilibrium equations? Now what are the equilibrium equations? Summation forces in the x direction is equal to summation forces in the y direction is equal to summation of moment is equal to 0. I mean, summation fx equal to 0, fy equal to 0, and moment equal to 0. Okay, so I write in a short way. Now these are the equilibrium equations, right? Now, why do we use equilibrium equations? We use equilibrium equations, like for example, to find the support reactions. Now see, consider a beam. Let us say this is a beam, okay, and there are supports, okay. This is one support here, and we have another support here, okay. Now, we usually draw these lines to ruler support, okay. And you applied a force at the midpoint. Let the force be W, okay. This is point A and this is point B. Now what is going to happen? Who will carry this? Who will carry W? Okay, this is the problem. Who will carry W? Now obviously you will say these two supports will carry them, right? But when they will carry, they will exert some reactions against W, right? Like this support A will exert a reaction on A, and support B will exert a reaction on this, like this. Okay, now this these lines indicate there is no x-axis motion. Okay, and how do you prevent a motion? When you apply a force against the motion. Okay, it means here must be another force which is not letting AB to move in the x direction, right? Because we have x-axis here and we have y-axis here. Okay, do you understand? These lines means this support will not let the beam move in this direction. Okay, but at the B support we have these small wheels, right? What are these wheels? it means roller. Okay, have you seen the shoes, the roller shoes, the roller skates? You know, the roller skates are something like this, where you put your feet on the roller skates, okay, and you can walk on the road. Okay, that means when there is, this is like a roller skate and the roller skate moves like this, right? If this is a roller skate, it moves. Okay, now this will allow the motion, right? These roller skates will allow the motion in what direction? In x direction, of course. No, now this support A does not let the motion, and these roller supports, they let the motion. Okay, now what is going to happen? Will the beam move or will it not? Of course the beam will not move. So what, there are rollers. Okay, here is a here this is fixed, right? When you see a bike, motorcycle like this, oh my god, I don't know what I made, and you're driving. Okay, you're driving it. Okay, this is a motorcycle and you are driving it. Okay, now this one is fixed. I mean, your wheel, the front wheel of your motorcycle is stuck in mud. Okay, here is mud or some pit in the road. Okay, but this here is okay. Now this will move, but this will move, but this will not move. Will the bike move? Will this motorcycle move? No, you will say no, because this will not let it move, right? It will just rotate here, skid. This will skid, right? Now that's what the concept is here. Anyways, I think we are going too much in deep in that. Now we have these two reactions at spot A and only one reaction at spot B. So we can just remove the spot to draw the free body diagram. Okay, we are going to just write an arrow here and an arrow here. Also we can remove this spot. Okay, and we can just use this symbol here, right? Now anyways, now this is A point, this is B, and this one is in the vertical direction, means in y direction, right? Now, so let me call this as A y, means reaction at A in the y direction, and let me call this as AX, reaction at A in the x direction, because it's in the x direction. Now let me call this as BY, reaction in the y direction. Now in this problem, if you are asked to find what is the value of AY, what is the value of BY, and what is the value of AX in terms of the W, what are you going to say? How are you going to find what is the value of AX, what is the value of AY, and what is the value of BY in terms of the applied load W? How are you going to do that? And you know, this is x-axis, the horizontal axis, and this is the vertical axis is y-axis, and these directions are positive. Now how are you going to do that? Of course you will use summation fx equal to 0. See what it is going to give. Summation of fx means summation of all the forces in x direction is 0. Why? Because this beam is not moving, right? There is an A support, as I have told you before in the bike example, that there will be no motion, right? Similarly here, this is not moving. It means this is not moving in the x direction. It means summation of all the forces in the x direction must be 0. Now how many forces are in the x direction? There is only one force. Okay, it is Ax. It means Ax is equal to 0. Okay, so this is 0. We found this. We applied summation of fx, right? Now let's apply summation fy equal to 0. Summation of fy is equal to 0. it means sum of all the forces in the y direction is 0. Why? Because it's not moving like this, right? It's not. It means now this ay arrow is same as the y arrow, so it's positive. By arrow is same as y arrow, it's positive, so we can write ay plus by. Now this w is also a force, right? But the arrow is opposed to this, means minus w, or I can write just plus. I can change the sign of w to be minus w, right? It is equal to, is there any another vertical force? No, so this is 0. Let's call this as equation first. Now what do we want? We want to find ay and by, but what do we get? We get ay plus by minus w equal to 0. We didn't get ay and by. Now we have applied summation fy equal to 0. We have applied summation fx equal to 0, summation fy equal to 0. Now we are going to apply summation of moment equal to 0. Okay. Now summation of moment is equal to 0. What does that mean? The sum of moment at any point, let us say for example at point B, is 0. Okay. Now see what it is going to give. Anyways, summation of moment at B is 0. Now how do you find moment? Moment you find force multiplied by distance, right? Let us say the total length is L, and this is at the midpoint. When it is at the midpoint, it means from here to here is L by 2, right? Because W is at the midpoint. Okay. Anyways, so the summation of all the moment is 0. Now there is moment at B. Now moment is due to force. It means summation the moment due to Ay at B plus movement due to AX at B plus movement due to W at B plus, is there any another force? No, so no plus, or yeah, there is another force, movement due to By at B is equal to 0. So let us find one by one. So it is, the forces is Ay multiplied by L, right? Ay multiplied by L. Now Ay is going to exert a clockwise movement, right? I am assuming clockwise movement to be positive. Now Ax, now you can see this Ax is passing through B, right? What is the distance between B and Ax? It is 0, right? Because it is passing through B. So we are not going to write, or we can write, okay, I don't care, Ax multiplied by 0. We don't write these things, okay? When we solve the problems, we don't write. I am writing this here just for explaining. Plus, now here is load W, and it is at a distance of L by 2, so it will exert a moment like this, right? Which is in anti-clockwise direction, means negative. Plus, so I will use a negative sign here, W L by 2, right? Is there another force? Yes, By, but By is passing through B, so the distance is 0, right? So plus By multiplied by 0. Okay, now this plus this plus this plus this is moment due to Ay, this is moment due to Ax, this is moment due to W, this is moment due to By. I have sum up all of these moments and I have to equate them to 0. Okay, this, it means all of this is equal to 0, right? Now this is 0, By multiplied by 0 is 0, right? So we are left with what? Ayl. Now plus and minus is minus, WL by 2 is equal to 0, right? Now here is L, this will cancel out with this L, right? So we get Ay minus W by 2 is 0. It means Ay is, when we take this term to this side, it is W by 2, right? What did we want? We wanted Ay By in terms of W. That's what we get. This is W by 2, right? Now remember this equation, this body here. Now here is ay, it is, I will write w by 2 here, right? W by 2, because I'm substituting ay in equation first, plus by minus w by 2. Now w by 2 minus w is what? Minus w by 2. So this equation will reduce into what? It is going to be minus w by 2, right? W by 2 minus w by 2, it is going to be minus w by 2, right? Plus by equal to 0, right? Now from here, if we take this term to this side, we will get by is w by 2. So we get w by 2. Now because of this, summation m equal to 0 and summation fy. Now this summation of fy equal to 0 gave you this equation, right? And summation of moment equal to 0, it gave you ay equal to w by 2, right? How did we get this? Remember, we get this because of summation of moment is equal to 0, right? That means when you apply both of them together, in fact all the three together, you are going to get the support reactions, right? Why do we use equilibrium equations? Why do we use these equations? Now you can say yes, we use them to find the support reactions. Now we have an example on how to find support reaction in beams. I think I have already provided the example. This was the example, okay? So we covered these two things together. This was the example, right? This was a beam, simply supported beam. We applied the summation fx equal to 0, summation fy equal to 0, summation m equal to 0. That gave us the support reaction, right? Now since ax is 0, so we can simply erase this, okay? We don't need to write 0 here. Now ay is w by 2, we can write here. This arrow is w by 2 value. Now by is w by 2, this is w by 2. Of course this w is at the midpoint of this beam, and it means the beam is symmetric, so these two will carry it half and half, but that is another thing. Those are symmetry rules, okay? My point is not that here. I wanted to explain what are equilibrium equations and why do we use them. Okay, I think you have understood this very well. If you understood this really, please give me a thumbs up or share it with your friends who are studying structural engineering or strength of materials, whatever. And please let me know if you have any problems to understand, and also if you need PDF of this lecture, you will download it in the description. I have provided the link there. And also if you have any problem on structural engineering, you can ask me and I will help you provide the solution, okay? And I think that's it for this class. I hope you enjoy. See you in the next class. Thank you.